So the next video is empirical and molecular formula. Empirical formula in particular comes up all the time and is an absolute gift because it's very straightforward, so make sure you're comfortable with it. I've given you a formula here at the top. It's the formula for glucose, C6H12O6. This is a molecular formula, and a molecular formula tells you exactly how many atoms are in a molecule. So 6 carbons, 12 hydrogens, 6 oxygens. The empirical formula is the simplest whole number ratio. So what I need to do is look at the numbers I've got in my formula and see if those numbers can be simplified. Is there a number that will divide in evenly to 6, 12 and 6? Yes, okay, 6 will divide in evenly. If I divide across by 6, I get CH2O. That's the simplest whole number ratio. So you can see that you've got double the amount of hydrogen compared to carbon and oxygen. Simplest whole number ratio is the empirical formula. In these questions, you're given mass and you're asked to work out what that simplest whole number ratio will be. So again, we're going to draw a table. Into that table, I'm going to put tin. So tin has the formula SN, and then I'm also going to put in chlorine. Now, I know chlorine is diatomic, okay? But chlorine is only diatomic when it is an element, okay? You are trying to work out the formula of tin chloride. Tin chloride is a compound, and you don't know if it's going to be SnCl or SnCl2 or SnCl3. So because it's in a compound and it's not an element, you don't know that it's diatomic. So I'm not going to write it down as being Cl2. Then I just do my G, Mr. moles, okay? I'm given 1.19 as my mass for tin, 1.42 as my mass for chlorine. I'm told the MR is 119, and I'm told here it's 35.5. So if I work out my moles, I'm going to get an answer of 0.01 for tin, and I'm going to get a 0.04 for chlorine. Now at this stage, you have to simplify the ratio, get rid of those decimal places. Easiest way to do that is look at both numbers, ask yourself which is smallest. Okay, so 0.01 is smaller than 0.04, and then you divide both numbers by the smallest number. So I'm dividing both of these by 0.01, giving me a ratio of 1:4. Your final step then is to actually write the formula. It tells you that that 1 is for the tin, so you've got 1 tin, and that 4 is for the chlorine, so your formula is SnCl4. The next question is it done in exactly the same way, okay? They pick A and G. They give you the mass, 3.5. They give you the mass of G. They tell you that this is 7 and that this is 16. All you're doing is 3.5 divided by 7 equals 0.5. And you're doing 4 divided by 16 equals 0.25. Again, simplify this ratio. You divide both by the smallest. You get a ratio of 1:2. And that your final answer then is A to G. So the 2 corresponds to the A, the 1 corresponds to the G. You have to write down the formula. If you just leave it as a ratio, you're going to lose one of your marks. This next one is going to be exactly the same, so I'm not going to do it out. But just again, remember, I know bromine isn't diatomic, but in this case, it's not an element. It's in aluminium bromide. It's in a compound, so we're not going to write it as Br2. We're just going to write it as Br, and then you work out what the formula is going to be. The next question combines empirical formula and molecular formula. So this one I'm going to do it, okay? So your first step here, you're asked to work out the molecular formula. And in order to work out the molecular formula, you're going to have to follow 3 steps. So I'm just going to write those steps here. Step 1, to work out molecular formula, is to get the formula mass of the empirical formula. Step 2 is to take the number that's given to you, to take the mass that's given to you in the question, in which case here it gets 284, and divide that by your answer to step 1. And in step 3, you'll take your answer to step 2 and multiply it by the empirical formula. Okay, now when I do this, it will start to make a little bit more sense, okay? But in order to be able to go through these steps, the very first thing I need to do is to actually work out what the empirical formula is. Now, sometimes they'll give it to you in the question straight away, but in this case, they haven't. So the first thing I'm going to have to do is work out the empirical formula. I've got phosphorus and I've got oxygen, so that's P and that's O. I'm told I've got 1.24 grams of phosphorus, 1.60 grams of oxygen. Phosphorus has a formula mass of 31, oxygen is 16. Again, we're not going to say it's diatomic because it's in a compound, it's not an element. I work out the moles of both, which I should probably be able to do in my hand, 0.1. I work out the moles of both. I simplify that ratio, so I'm going to be dividing both of them by 0.04. Okay, pay attention, that one is smaller. So I divide both of them by 0.04, and I get a ratio here of 1 is to 2.5. Now be careful here, okay? You can't just round 0.5 up to 3, okay? You've got a half. To make it a whole, you're going to need to multiply by 2 because there are 2 halves in a whole. So if I times that by 2, 2.5 times 2 is 5. To keep the ratio the same, I also need to multiply the other side by 2, and I get P2O5. That is my empirical formula. Now that I've got my empirical formula, I can work out my molecular formula. So empirical is the simplest whole number ratio, but molecular is the actual number of atoms in the molecule. So step 1 is work out the formula mass of the empirical formula. That's going to be work out the formula mass of P2O5. All right. I know that phosphorus has a mass of 31. There are 2 phosphorus, so it's 31 times 2. I know oxygen has a mass of 16. There are 5 oxygens, so it's 16 times 5. So if I work that out, 16 times 5 plus... So I work out that the formula mass is 142. Okay, so that's step 1. Step 2 is take the mass I'm given in my question, which is 284, and divide by my answer to step 1. So I divide that by 142, and I get an answer of 2. And then my final step is take my answer to step 2, which is 2, and times it by the empirical formula. So empirical formula is P2O5. I times that by 2, and I get P4O10. And that is my molecular formula. So in phosphorus oxide, I've got 4 phosphorus, 10 oxygens. That's my actual molecular formula. But the simplest whole number ratio, I've got the number 4 and the number 10. If I divide across by 2, I get P2O5. And that is my empirical formula. The next question, titanium and iron, blah, blah, blah. No, you've got iron and you've got oxygen. So again, you've got iron, you've got oxygen, 2.24, 0.96. Again, I'm dividing by 56. I'm dividing by 16. It's not going to be diatomic. It's in a compound. And I get 0.04, which I seem to be getting a lot. And 0.96 divided by 16 equals 0.06. So again, smallest of the 2 numbers is 0.04. So I divide across by 0.04. And again, I get an answer here of 1.5. To get rid of a half, I need to multiply by 2. So I get a ratio of 2 is to 3. Okay, that means the formula for iron oxide is Fe2O3, and they ask you to use that to finish off this balanced equation. So you now know what the formula of iron oxide is. You can fill it in here, and then you need to balance your equation. You've got 2 oxygens on the left, 3 on the right. If I put a 3 here and a 2 here, then I'm going to have 6 oxygens on each side. By putting that big 2 there, I've got 4 irons, so I need a 4 here. Okay, and that's the end of that one. So that's empirical formula. There's only one example of molecular formula. It doesn't come up as often, but if it does, like in this case, it's worth 4 marks, and it's really straightforward once you know what these 3 steps are. So make sure you do learn your steps.